We're gonna try to see a lot of different aspects of this kind of talk today, and we'll be talking about different kind of attacks that we have performed on various vendors and websites, and then we'll show how that leads to malware. The basic point of this talk is to just stick to the basis and change your modus of operandi and try to look into the things that how we can take care and control of the servers through web apps and how disastrous this can be. So a little bit background about me. Before getting into about me, like all the vulnerabilities that I'm going to discuss in this talk is solely on me and nothing it relates to any of my employer. And we have a certain dependency of this talk to be anybody who is good in pen testing and assessment reviews, going to learn a lot of new stuff from out of it. So just a little background of me. I really run my own Technical Security Labs as a open, free web application security arena where I do a lot of research. I also have a PhD candidate at Michigan State University. Still, I also consult for Armorize. I previously worked for Cozing. It's a pretty specialized company in Singapore based on computer and vulnerability research. And also work for KPMG as a consultant. I do write a lot of stuff for the very new Hack in the Box design, and I'm the lead author for there. So if you really want to check out the stuff on web app and how we spawn into database centers and all that things, high mass SQL injection attacks, so I just recommend you to go and check that Hack in the Box design. So the little bit of notification is that all the vulnerabilities discussed in this talk are in the process of patching and will be patched in the month of October. But still, I just want to discuss over these factors because these are really good stuff to learn, and we can learn a lot out of it. And once we go back and apply in our required field, so it's going to be a great manual testing. So a simple agenda for today is we're just going to look at for 5 to 10 minutes, not 5 to 10 minutes or 5 to 7 minutes into the Web 2.0 framework. Then we straightforward jumps into our web vulnerability hunting. We're going to talk about cross-interface attacks. We all know about XSS, but I will show you when the modus operandi changes, how the base changes. So then we're going to talk about SQL XSI, then document rendering attacks, web widgets, how these can lead to a lot of flaws, and persistent redirection attacks, declarative security manipulation, and insecure content inclusion. So the 7 attacks which I'm going to discuss is all these web vulnerabilities have been found in the very high-oriented vendors, devices, as well as, the very high, you can consider about big companies that are having an open service providers for example, Yahoo, Google, and everything. So we're just going to continue with our talk and we'll look at what the Web 2.0 looks like. Well, this is a mesh. It's a mesh network, it's a mesh network. So both aspects are there if we talk into pros and cons of the particular Web 2.0 framework. So we are not actually relates if we are sitting at the client side, we are just communicating with the server side. This is not right now. The information is not actually shared between only 2 parties, but it's just getting centralized and diversified between various spheres. So that's why we have social networks. So if we're using a particular type of RSS feeds, then we are providing that feeds to third party. So you blog, your content go to third party. So the point of thinking approach here is so where is the security barriers? If we think we are secure enough with our websites, but what about the issues that reside on the third party? So if your information is getting traveled from one part to another, it carries the risk as well as the kind of positiveness in your content at that point of time. So if we look at the 2009 web trends, we feel that not even a single domain that is being untouched by it, whether it's the educational domain, financial, and everything. So if we consider an aspect of malware writers, they are more prone to attack into financial applications. That's pretty true. But most of the attackers, the young kids, they are really gone into the educational websites, university websites, stealing all the stuff. So the point of consideration is that not even a particular domain that is being touched by the web vulnerabilities and even malware. So if we look at the web vulnerability classification in 2009, we have the state one. OWASP, provided his 2004 classification. Then we jumped back into 2007, and then straightforward after into 2010. So maybe there are 2 or 3 different variations in attacks in the kind of the specification they provide for the vulnerability, but majority of attack remains the same. So if we look at the browser states, because since we cannot say if we are talking about the web vulnerability clients and server, the browser is the kind of element that provides us the window to the World Wide Web. So if we have enough vulnerabilities, that client is looking at it, so it's going to be through browsers. So browsers do a part of this composite security. So if we look at this, so this simply gives you an idea which browser is getting more exploited within a period of 2009. This is stats by Sensei, and I really like the way they provide stats based on these considerations. So before getting into the real world attacks and the kind of issues and vulnerabilities we have given, the point of talk is here why the exploitation is shifting from system to web. Because the major thinking we have to look into this aspect is system vulnerabilities are getting harder to exploit because more and more protection mechanisms, people are good in finding vulnerabilities in Microsoft Word, Excel, but it's getting real harder to exploit if we consider Windows 7 platform as well as if we consider Windows Vista. But still we have exploits, but web opens more wider window to the people. And since we are all, with the advent of like social networks, we are having a human touch with it. So as long as your information is posted on one thing, get on to the other. So if we hack into one website, for example, share hosting. So we have enough n number of websites hosted on it. If you get hacked into one, you can serve malware from a lot number of websites on it. So the thing is that web provides us the more wider window for exploitation. And since things are and web vulnerabilities are easy, we are having an interface with the servers, and servers having an interface with the system, the kind of operating system they run. So the exploitation is really getting shifted. So these are some of the points which actually strengthen this aspect. So the point of talking about Web 2.0, about their framework, is to just get a little understanding of what we are going to discuss after this. And web application security, this is not a singular component. It actually depends upon a lot of things. So even if you look at this, a robust web application would have a good development, a very profiled security. We have a reliability, privacy and design. So if you think if any one out of this component misses, we will going to face some kind of stringency, and that will really impact our stature of using that particular technology. So what about the web application vulnerability hunting? So there are a lot of pillars based on that, as I mentioned in the last slide. So we have a design and development, then we attack and exploit, then we patch and rebuild. So all these 3 things matters a lot. So if you have an issue in one, it frees back to the second, and it goes back to the third. So all these things are really interdependent. So web vulnerability depends a lot of not looking into one aspect, but a lot of different aspects. So with that, I'm going to start with the cross-interface attacks. And the idea and the motivation behind to understand this kind of attack is we are having an embedded devices, we are having firewalls, we are having disk station managers, storage provider devices, which are having a web application interface. But we always look into the path that, okay, it is having a web application, we can conduct cross-site request forging, and we can, do the remote command execution. For example, if we have any disk station which provides a web application interface. So the idea behind this attack is the base is XSS, but the thing is how we conduct it, that is quite different in this case. So if we look into the idea is most of these devices use administrative interfaces, whether it's FTP, Telnet, or a web-based console. So we have a username and password field. For example, consider web application. They have a user input and a password input. You put something payload, it works. You got access. If not, you think logs up. But what about, have you, ever tried something looking into the aspect of using FTP backend console to attack web application? If anyone would think over that scenario, because there is a question in front of us whether these devices can serve malware. So that is the thing. So we tested a lot of web devices which are using this web application interface, and then we come across with this idea of cross-interface attacks. We gave this vulnerability to one of the highest number of, the vendor which provides highest number of these disk station managers in the US. And this vulnerability is going to be released with Checkpoint, and they are patching that thing. So the idea of attack revolves around thing. We try to use into FTP or the Telnet console, but in this case, I used FTP. So our, the endpoint is not to get logged into the application, not to just get to the access to the application. The idea is we need to generate errors. So in this tag, we find a vulnerability in that. So it means like whatever you're going to generate is going to logged in. So the thing is how we get into the nitty-gritty details, and we'll see how we can exploit it. So if we have an FTP, administrative interface, we have username and password. No need. The idea is to generate as much maximum errors as you can. So the FTP has a stringent truth. So if you provide your username and it verifies it, it's a bad design practice because you can enumerate number of users. So if it takes username and password then allows you to access, that is the thing. But our research says that if we get F30 login incorrect password, so whatever the kind of characters you provide in that string, when the FTP asks for password, it truncates that string. So if you provide like buffer of 100 characters, right, and it will say enter the password for 60 characters, right, and it happens. So what it gives us an idea that we can use the 60 character string to launch our payload through FTP because we don't want access, we don't want into the application, we just want to generate errors. And what we actually did, this is just a small scenario. We just logged into that application and we just provided the buffer, and when password asks for buffer, it gives us the exact string that we can use to set our payloads. And once we do that, we really get the control that what kind of buffer we can provide, and so that we can generate automated scripts that continuously generating errors in it. So what happened actually, if we look at that console and we looked into FTP, we inject like the kind of HTML tags or some other payloads based on XSS. We termed it as a cross-interface attacks because the interface is not from the web to web. The interface is from the backend login console to the web. So if your website filtering is not good, so you can do these kind of attacks, you can inject this. So what actually happens is this. So this actually gets rendered into your logging console. So whenever the administrator gets into the login console and see blah, so what actually happens, it will start serving the malware onto the disk station manager and the servers which is actually hosting it. So this is actually a great scenario. We can do drive-by download attacks. We just want any kind of browser that guy is running, we just fingerprint it, then we can serve that exploit through this kind of attacks. So this is really serving the malware at the server level. And so if you consider aspect, can these type of attacks be noticed by the automated scanners? Pretty hard. And I don't think so it's possible. And because basic scanners look for the tainted operations and a kind of input points, but this kind of input points, nobody is going to check like payloads to FTP, then render it in the devices which are having vulnerabilities in their logging interface. So what we did after that, we try execute ActiveX code execution, VB script is possible, heap spray, and Ajax calling. So just I designed a Perl script, run through server, bang the logs, fill that logs with the malicious input. Whenever just try to the administrator get into that console, blah, and bangs is over. So it starts serving malware on the server level. And serves at the server level will get onto the client side. So this is really a bad scenario of this one. And so this vulnerability will be patched soon, and the upgraded version of that vendor product will be available soon. The second attack which I'm going to talk about is SQL XSI. I think everybody talk a lot about SQL injection, cross-site scripting, and all that things. But with the recent advance we have, we work pretty specialized in web malware analysis. We see that